Welcome to the EC2 Mitre Attack Workshop. We're going to simulate an AWS account breach from start to finish, starting only with remote web access and ending with administrator access. And to do that, we're going to be making use of the Mitre Attack Framework, which is an open source threat modeling framework, which has 14 different categories and subcategories within each of those, starting with reconnaissance and going all the way to impact. And along the way, different steps such as execution, privilege escalation, discovery, lateral movement, and command and control. Let's take a look at reconnaissance. Some of the subcategories here is active scanning, and within active scanning, we can drill down to different types of active scanning. One of them is wordless scanning. So let's take a look at that. It gives you examples of how to do that. For example, a tool called GoBuster can be used to brute force web directories and DNS subdomains. We're going to take a look at brute forcing both of those in this workshop. This also gives you mitigation. So how do you block these types of attacks? What can you do to help prevent them? And it also shows you how to detect them. So let's take a look at the workshop. You can get there by going to tinyurl.com/Mitre workshop. That'll redirect you to my GitHub page. From there, take a quick overview of it. It's got a number of different steps, and these map directly to the Mitre attack framework, starting with step 1, reconnaissance, and going all the way to impact. We're only going to do 10 of the 14 categories. The Mitre attack framework can be customized to your particular use case, so you may not use all of them and certainly not every subcategory. So let's begin. So at the top of the GitHub page, you'll see a button for Launch Stack. Go ahead and click that. This will take you to CloudFormation. We're going to launch everything as infrastructure as code. It'll take you to the US West 2 region automatically. Go ahead and click Next. It'll need your source IP address. Since this is a vulnerable environment, it's going to be restricted to just your IP. I also recommend terminating the stack when you're finished with the workshop. And then it needs a domain. So if you have your own domain, you could use that or use a subdomain. I'm going to use nick.cloudsecurityworkshop.com. Everything else could stay the same. If you're using an existing AWS account with a VPC that starts with 10.0, go ahead and change that. However, if it's a new account, that is not required. For the size of the tools instance, one of the tools requires a T2 medium. So this is outside of free tier. It will only cost 50 cents or so for the workshop, even if you use the medium size instance. Everything else could stay the default. I like to check this box, preserve successfully provisioned resources. If for some reason the stack does not finish, it will keep all the resources that it could complete and also show you which ones failed and why it failed. So go ahead and click Next. Check both of these boxes and click Submit. This will create a number of CloudFormation stacks, which creates all the resources for this workshop. All right, and our CloudFormation stack is just about done. Route 53 is the last stack. So far, it's been going about 5 minutes. And there are no rollbacks, which is good. So let's go ahead and take a look at Route 53. Since I am using a subdomain here, I'm going to need to enter the name servers in the account which manages the main domain. And to get the name servers, I'll click on Hosted Zones. And then nick.cloudsecurityworkshop.com, which was the subdomain I selected. So I will copy these and then go to the account which has cloudsecurityworkshop.com in it and create an NS record for the subdomain nick. Okay, I've just done that off screen here, and it will take about 60 seconds to update. Let's go back to CloudFormation. Still creating. We'll give this another minute or so to create. While that's working, let's take a look at some of the resources it created. If we go to EC2, we will see two instances here. One is a public web server, and the other is a PenTesting tools server. This is our T2 medium. This is going to be our command and control server where we're going to do the attack from. Normally, this would be one in a separate account. You wouldn't have access to a server in the target account. However, for the workshop, it will be in the account. However, we'll start out with just only remote commands, so it will simulate a remote server. It's still initializing. Let's go ahead and connect to it. And this already has a number of pen testing tools already installed, similar to what you'd find on Kali Linux, except for cloud specific. So I connected using the session manager. Let's go to EC2 user after sudoing to root, and we'll see a folder called pen testing tools with a number of tools already in there. So now let's take a look at what the web server is. It's a publicly available server, so if we go to our subdomain now, so it'll be nick.cloudsecurityworkshop.com. We see it's a website, so it's only an under construction page. So what can we do here? Let's find out. Remember, we looked at the Mitre attack framework, and it said we could scan for DNS subdomains with GoBuster or even web directories. Let's scan for subdomains. The command for that is going to be GoBuster DNS-W for word list. I'll put the full path here. And I'm using the tab autocomplete. We'll go ahead and use the small list. Depending on how much time you have, you could use the big list. For this workshop, we'll just go with the small one, which will be sufficient. And then it's going to need -D and the domain that you're trying to scan. Remember to remove the trailing slash and the HTTP:// in front. Let's let that run. So it already found a couple of subdomains. It found www and also finance. www just usually maps to the home page. It is a good idea to still check that. But what we're particularly interested in is finance. Let's take a look at finance. Okay, so we have a back-end system here. It is password protected. Let's try some basic logins such as admin. That's not working. We could use a tool like Hydra or something to brute force the logins or try common logins. But let's actually scan this subdomain and see if we could find anything that may not be password protected. So it was still scanning the DNS, but I'll go ahead and stop that. Normally you would let that continue. So this time, instead of GoBuster DNS, we're going to use GoBuster dir-w again for word list. This time we're going to use a slightly different word list. We'll use one that's web content specific. and actually go for common PHP file names. And all these commands are on the GitHub page, so you could copy and paste from there. And it's going to need -u for URL, and then the URL, which in this case is the subdomain, so finance.nic.cloudsecurityworkshop.com. Here it's a good idea to put the trailing space and also the prefix. So if it's just HTTP, HTTP:// or if you're viewing it over SSL, it would need the S. So this finished fairly quickly. It only took a couple seconds to run, and it found index.php, which was most likely the home page that it defaulted to, and it also found one called reports.php. So that's interesting. Let's take a look at that. Okay, and we got this to load, so we found a page that wasn't properly password protected. And within the accounting backend, we see some different links here. Let's go ahead and click on the first one, Q3 2022. And we see this is a financial statement from the third quarter 2022. So what can we do from here? How can we get administrator access just from this? So we already went from just an under construction homepage to accessing a page on the back end. Where do we go from here? So I see there's a URL parameter, query parameter, and it's pulling this report from S3. So this view report.php page, which wasn't picked up by the scanner, but we were able to find it by clicking on the link, takes in this case, a CSV file from S3 and generates this table or a report from it. So what can you try here? This looks like a prime candidate for an SSRF attack. Let's try the metadata URL, which is 169.254.169.254, and see what happens. So it says invalid URL. So the view report page, it actually checks the URL to make sure you're not trying to get the metadata. Are there any other ways to get the metadata? So this is just one URL. One thing that's common that people do not block are alternate variations. You could use hex characters instead of numbers for the IP, things like that. Or there's also a word you could use, instance-data. So let's take a look at that and see if anything comes up. And here it is. So instance-data is the same as the 169.254 metadata URL. So we see that there's latest. That's what we want to go to. And then in there, metadata, which is what we're looking for. And what we're hoping is that there's a role attached to this EC2 instance. And we're going to try to get the temporary credentials for that role. If we do get those, they're good for 12 hours and can be used remotely. So now let's look at IAM. And then security credentials. And then we see a role name here. So this is EC2 SSM role. So let's put that in. And we see we did in fact get the temporary credentials. Now let's go back to our command and control server. Let's check what user we currently are. And we do that by using the AWS STS get caller identity command. So we see where our EC2 role, now the other one was similar except that was EC2 SSM role, so a different role. And also note the instance ID here. Let's go ahead and assume the role using these temporary credentials. We'll do that by using export. So we need the access key ID, the secret access key, and then the token. So we'll do export AWS access key ID equals. Now we'll do export AWS secret access key. I'll go ahead and copy that from our SSurf attack. And SSurf is one of the OWASP top 10, so this is a very common type of attack. Now we'll export the session token. And that's this big long string here. So now, did this work or not? How do we know? Well, we could run our get caller identity command again. And we see now we're EC2 SSM role instead of just EC2 role. And we also see the instance change. So we're assuming the role of a different instance now. So we've just completed step 1, reconnaissance, and step 2, credential access of the Mitre attack framework. Now let's go on to step 3, discovery. So now that we're the role of the web server that we just compromised, let's see what else is in the AWS account. For that, we're going to check out a tool called Scout Suite that's already installed on this tools instance. We're going to start a virtual environment. A lot of these tools require different versions of the same Python libraries. So by using a virtual environment, you could use different versions of those libraries without having to uninstall or reinstall anything. So we'll go ahead and activate it. And the command to run Scout Suite is Scout AWS, and then you could specify the number of max workers. I like to use 3. This actually goes through and checks all regions, so it takes a couple minutes to run. And what it does is it looks for common security vulnerabilities within your AWS account or the account you've compromised. So if you've compromised an account, this is a good tool to get a quick visual of what that account has, where some of the vulnerabilities are, how you might be able to escalate your privilege faster. All right, so this just finished. Took about 5 minutes to run. And let's take a look at LS, see what we have. So it created a directory called Scout Suite Report. Let's CD into there. And we see an HTML file along with some directories. Let's go ahead and start a Python web server with this command here, python-m http.server 8001. So 8001 is the port we're going to use to start the web server on. And this will allow us to view any files within the current directory. And since the security group restricted it to only our source IP, we'll be the only ones who are able to see the Scout report. So let's go back to the domain here. Correction, let's see. We'll go to the main domain, although it may not matter. Oh, correction, this is the web server. We need the IP of the tool server. So we'll copy the IP address of the tool server and now go to port 8001. And this is not over SSL, so we'll use HTTP. Okay, so we see a directory listing and the HTML file that we saw by the command line. Let's click on that. And this is the Scout report. So this shows all the services that it checked, along with how many resources it found, what rules it checked against, any findings, and how many total checks it did. So for instance, EC2, it had 67 findings. We could check on that and see what the issues are. IAM is another good one to look at, 23 findings here. For example, IAM pass roll is allowed on an inline policy, and that's for role 3. So make a note of that. We're going to come back to this later on in the workshop. Another thing we could look at is STS assume role for all. That's a good one to look for. We see that again down here in a managed policy. So this is Scout Suite. Let's take a look at another tool now, one called Cloud Mapper. Let's go back to our command line, Control C to stop the web server. And we'll go into the Cloud Mapper directory. For this, we need to modify the config file. So nanoconfig.json. It's going to need your account ID of the AWS account you're in. Otherwise, it'll give a warning saying it also needs your IP address, and this is where it gives the warning. If the IP is not recognized, it shows that the warning that this unusual IP has access. And then if you have a particular location, you could put, so for example, San Francisco office. And then for the account, it needs a name. Use anything except demo. If you use demo, it loads a demo data set. So we'll go ahead and save that. Now, similar to Scout Suite, we're going to use a virtual environment. So let's create and activate our virtual environment. Cloud Mapper has a few more steps, so we're going to first collect. Then we are going to report, so we'll run cloudmapper.py report. Then we're going to prepare, and then we're going to run web server and also make the web server public, but it's not actually public because it's restricted to our IP. So this again checks multiple regions, so it'll take a while to run. And this is a good tool to be used alongside of Scout Suite. Rather than using one or the other, it's good to use both. They're very different results, and we'll take a look at the Cloud Mapper result momentarily once this finishes. Okay, if you get any errors, it's safe to ignore. We'll go ahead and now run report and prepare. And again, Cloud Mapper is part of the discovery step. So that's step number 3 in our workshop. So now let's run web server, and this starts it on port 8000. So instead of 8001 that Scout Suite was running on, this is port 8000. So simply replace the port number in the URL. And again, this is the IP address of the tools server. And this creates a nice map for you. So it shows what resources are in what subnet. So for example, in this public subnet, we see our web server and our tools server. We also have a subnet with some Lambda functions in it. And this is actually a database subnet and a private subnet. So if we had access to the public web server and wanted to compromise a resource in the database subnet, we would see the relationship here with one of the arrows. And essentially we have one for each availability zone. And this one is separate since it's a public subnet and it has public access. So if we look over here, that shows who has access to it and if the internet can access it. And then also, one nice thing about Cloud Mapper is when you click on a particular resource, like for example, the web server, and then click on details, it gives the details of that EC2 instance. So you'll see things like the IP address it has, different things about the security group, other information that could be used in compromising the account, even has the VPC ID and subnet ID. So that is Scout Suite. Let's go back to our terminal. We'll go ahead and stop that web server. So a couple other exercises as part of the workshop that I will leave to you are step 4, lateral movement. So which resources could you go to laterally? Either now or later on when you escalate your privilege. And then step 5 is going to be privilege escalation. This is the biggest step, the one that'll have the most impact. This is where we're going to try to get administrator access. So starting with just public website address, the same as just viewing the website over the internet, we're going to try to escalate that to CLI AWS administrator access. One good tool for this is a tool called Paco. I'll leave this as an exercise to you. There's some instructions on the GitHub page that show how to use it and the different modules. However, in addition to using Paco, you should know how to exploit manually. So let's take a look at the manual method. So let's go ahead and list out the roles. And we want to filter the results, so we'll use the query command. So we have IAM list roles and then query roles, role name, and then principles, which we get from this assume role policy document. So we want to see what principles are in the trust statement for for the different roles. So this is doing it page by page. Remember the role we saw in Scout Suite was role 3. What we actually want to look for here is something that allows this ARN. So this is an IAM ARN, but the principal is root. Now this actually doesn't mean the root user for the account. This means any user or role in the account. So if this is in a role, any user or role within that account can assume that role if they have STS assume role privileges. So let's do this. We'll do a grep here. And there's an extra quote, so I'll remove that. Okay, so we see all these roles have this trust policy that allows root. Now, some of them may be limited to a particular service, or some may have an external ID, something like that. However, as a pen tester, it's good to check all of them. We will look at role 3, so let's do IAM get role, role name, role 3. And we see the trust policy, which is this assume role policy document. It is root, and action is assume role, and there's no condition based on service or external ID. So this will be a good one to try to assume and see what permissions it has. One thing we could also do, because we're have a role now that has read-only permissions, so or at least I am read-only permissions. So the role that was attached to that web server that we compromised has I am read-only access. We could take a look at what a good role might be to compromise and try to escalate our privilege to. So the policies attached to this role 3 are support user, which doesn't have that many permissions. However, let's see what else it has. So that was attached role policies. Let's try just role policies, which is inline policies. And we see there's a policy called policy 1. So let's see what that policy 1 is. AWS IAM, get role policy, role name, role 3, policy name, and it was poll 1. Okay, so we see this is IAM star role permissions on star resource. So this is a very vulnerable policy. So if we were able to get to role 3, if we could assume role 3, then we would have more IAM permissions and could even escalate our privilege even further. So let's go ahead and try to assume that role 3. So what we're going to need is the ARN of that role. And if we know the account number, we know the ARN. So let's run the assume role command. Now it's going to need the account ID. And a role session name, which could be anything. And there we go. We have temporary credentials for that role. Now, if we do a get caller identity, my session timed out there. Just a second while I reconnect. Okay, I have reconnected. I'm using single sign-on, so my sessions are good for 1 hour at a time. So now I'm going to export these temporary credentials the same as we did before. So it's going to need an AWS access key ID. And it's going to need an AWS secret access key. And it's going to need the session token. So now if we run AWS STS get caller identity, we'll see what role we are. And we are role 3, which is the one we were trying to assume. So let's see what we could do with this. Can we create a user? I'll try creating one called do admin, and this is not allowed, so that's blocked. Let's see what else we could do. So let's try creating a role now. So for that, we're going to need a trust policy. So let's do nano trust poll.json, and I'll copy one from the account. The format is standard, so you're able to recreate this without any access to the account. But for instance, if we were to look at the trust policy here, we could use the same one here. And the spacing is a little bit off when you're using the session manager. So I'll go ahead and fix that. A lot of times, if you had internet access, you could download this with wget rather than copy and pasting it. And that looks correct. So we'll save that. Now let's try to create a role. It's going to need parameter called assume role policy document. So that'll be the trust policy we just created. And there we go. We were able to create a role. So what else could we do? Let's try to attach the administrator policy to our current role. Escalate our current role 3 to administrator access. And the command didn't give any results, but it didn't give an error message either. Let's see what policies our role has now. Remember when we checked it before, it only had support user. So let's see what we have now. And there we see there are two policies attached now. So the second is administrator access. So we've just escalated ourselves to administrator access. Now let's try to create a user. Remember before this command did not work, but now that we're admin, let's see if it works. And there we go, we were able to create a new user. So that completes step 5, which was privilege escalation. So step 5 of our Mitre attack workshop. The rest of the steps I'll leave as exercises to you. So that includes step 6, defense evasion. How would you avoid being detected within AWS now that you're administrator? So what you could do, maybe delete the CloudWatch log group, maybe delete the CloudTrail, or at least stop CloudTrail loggings, or modify some of the CloudTrail settings. You could tamper with security services, AWS config, security hub, etc. You could delete logs from S3, or maybe put a bucket lifecycle on the logs bucket with a very short expiration time. So delete them every day, for instance, so that once if they do suspect suspicious activity, the logs likely won't be there. Next up is persistence. That's step 7 in our workshop. So that would be like creating access keys for this user or creating a second set of access keys for an existing user. Step 8 is collection. Now that you're admin, what other data can you get from the account? Can you exfiltrate any data? Are there any crown jewel assets you want to find? This often requires other tools here. So one tool I like to use is called Truffle Hog. So I'll show you an example of this command. It's not specific to the account we've just compromised, but Truffle Hog is good for a number of things. For example, scanning Git repositories, for scanning S3 buckets, or even file systems. So now I'm going to run it on a sample Git repo that I have. So the command for this is just trufflehog get and then the URL to the repo. So it found a number of things already. It looks for different things like private keys. It looks for AWS credentials. So some WordPress plugins require you add an access key to the config file. Trufflehog is able to find that and give you access to whatever role that AWS role had. It also finds ID RSA file, so that's the SSH key. So this will likely get you into EC2 instance using SSH. And then it finds just other things, so even private keys that are used for encryption. So maybe with one of those, you're able to decrypt data, things like that. So it's a great tool to use. And then the next step you might want to look at is exfiltration. So copying some of this data out of the compromised account. This could be copying S3, so an S3 to S3 bucket copy. It could also be exfiltrating snapshots. So you might want to go into EC2 and share some of the snapshots with your own account, and then copy them or create an instance with that snapshot. Same thing with RDS, using it with RDS snapshots. And then finally is impact. This is what you want to do after you've compromised an account. And this will vary greatly by use case. If you're just doing a pen test, you may want to just add a tag to certain resources to let the client know you're able to get in and modify resources. However, it could even be shutting down a web server. It could be defacing a website or installing malware on the website. Depends what your end goal is. And then finally, just the last step of the workshop is cleaning everything up. Because we modified this role 3, it may not delete automatically by CloudFormation, so you may want to delete this role first. And then delete the stack. So to delete the stack, just go to CloudFormation. And we used a nested stack when we create it. So go to the bottom one. So that's the one that's just called EC2 Mitre Workshop with nothing after it. And then click the delete button, and this will go through and delete all substacks as well. So this concludes the workshop. I hope you enjoyed it.